Hello students, welcome back to my channel. How are you all doing, students? Hope all are doing good. And what about your preparation for the exams? I think within 1 or 2 months you will be writing your end semester exams, right? Okay, so you might have seen the thumbnail, so you must have understood which topic I have taken in today's video. Yes, students, this is all about geometrical isomerism, which is under stereochemistry of carbon compounds. Especially this is for B.Sc Second year students. So please kindly second year students and those who are preparing for MSc entrance exams also can follow this topic. And please kindly note down in your notebook, students. Okay, so what is this geometrical isomerism? I told you this is this belongs to stereochemistry of carbon compounds. So we can say that geometrical isomerism is one type of stereoisomerism, and we can see this geometrical isomerism in compounds containing carbon-carbon double bonds. That means where there is a double bond between two carbon atoms, in such compounds we can find this geometrical isomerism. Okay, students. So I have mentioned the first sentence that it is a type of stereoisomerism which exists in compounds containing carbon-carbon double bonds. This is the first and foremost sentence which you have to write under geometrical isomerism, because you should know in which type of compounds we can find geometrical isomerism. So I told you this is one type of stereoisomerism. So you should know what stereoisomerism is, right, students? So without knowing stereoisomerism, we cannot move further. So below I have mentioned stereoisomerism definition also. So before knowing stereoisomerism, we should know what stereoisomers are. Then we can mention that phenomenon is called as stereoisomerism. So what are stereoisomers? Are you ready, students? Yes, these are the compounds which have similar molecular and structural formulae. You have to underline that point, students. The compounds having same molecular and structural formulae. So if you look at their molecular formula and structural formula, we find that the two compounds will be having the same molecular and structural formula. Then in which part they are differing, that you should know. But different spatial arrangement. What is this spatial arrangement, students? Arrangement of atoms or groups in space. So they will be, the two compounds will be differing in the spatial arrangement of atoms or groups, and such compounds are known as stereoisomers. Are you able to see, students? Are known as stereoisomers. Okay. So once you know what stereoisomers are, you can just write down, and the phenomenon is known as stereoisomerism. Okay, so shall I repeat, students, once again? Yes. Put the side heading stereoisomerism. You can write the compounds having same molecular and structural formulae but different spatial arrangement of atoms or groups, but different spatial arrangement of atoms or groups are known as stereoisomers, and the phenomenon is known as stereoisomerism. Okay, so once you understood what stereoisomers are, you can easily write down, or we can easily understand what geometrical isomerism is. So before knowing geometrical isomerism, we should know what geometrical isomers are. So these are the isomers having same molecular and structural formula, but they will be differing in the spatial arrangement of groups or atoms about the doubly bonded carbon atoms are called as geometrical isomers. and the phenomenon is called as geometrical isomerism. I will show you the representation of geometrical isomers, students, so that it will be easy for you to understand. So little bit look here, come down and see. I have given two representations here, students. See, the main important point is geometrical isomerism. The two isomers will be differing in the spatial arrangement of groups or atoms about the double bond. See, I have taken here, this is one compound, this is one compound. Here you can find a double bond between two carbon atoms. In this also there is a double bond between two carbon atoms. And the atoms or groups present around these two carbons are A, B and AB. Here also AB and BA. Both have the same structural and molecular formulae, students, but they only differ in the spatial arrangement. What is the difference? A, B, A, B. So both sides there are, same side there are both the similar groups. Here you can find A on the same side, B and B on the same side. Coming to the next compound, C double bond C. Here you cannot see similar groups on the same side. A is here, B is here, B is here, A is here. So this is what we call it as difference in the spatial arrangement of groups or atoms. Okay, students. When the groups or atoms, similar groups or atoms present on the same side, we call it as cis isomer. What is that? CIS, cis isomer. So when they are present on different sides or opposite sides, similar groups on the opposite sides, A, B and B, we call it as trans isomer. So the two geometrical isomers are, one is cis isomer and the other is trans isomer, students. Hence we call geometrical isomerism also cis trans isomerism. Okay. So understood, ma? Right. Now just look at the sentence which I have mentioned here. The isomers which differ in the spatial arrangement of groups, spatial arrangement of groups about the doubly bonded carbon atoms. About the doubly bonded carbon atom. Underline this doubly bonded carbon atoms, students. Doubly bonded carbon atoms are called as geometrical isomers. See, I underline geometrical isomers, and the phenomenon is called geometrical isomerism. Clear? Next, moving on to the next point. The isomer in which similar groups, so A I mentioned, right? B. Similar groups lie on the same side of the double bond. Lie on the same side of the double bond. What is it called, students? Do you remember? Yes. It is called as cis isomer. Is called cis isomer, and the isomer in which similar groups lie on opposite side. Lie on opposite side is called as trans isomer. So underline similar groups lying on the same side. Similar groups, underline, same side, underline, and such isomer we call it as cis isomer. And also underline, students, similar groups, opposite side, trans isomer. Therefore, geometrical isomerism is also called as cis trans isomerism. Geometrical isomerism is also called as cis trans isomerism. Okay. So below that, draw these two representations, students. Okay. So below the first one, write cis isomer, and the right side one, this is trans isomer. Okay. So if you see these two representations, immediately you will have a clear-cut idea about geometrical isomerism. Okay. Now we will see a few examples for this geometrical isomer, students. Example number 1, 2-butene, students. 2-butene. What is this 2-butene, students? But means 4 carbons. So ene means double bond. 2 means the double bond is present at the second carbon. Okay. Look here. This is 2-butane students. CH3, CH double bond, CH, CH3. Numbering 1, 2, 3, 4. So double bond at the second carbon. This is called as 2-butane. So we can show cis isomer and trans isomer of 2-butane. Look here. Doubly bonded carbon atom C double bond C. Okay. So starting with CH3, CH, CH, CH3. Second carbon double bond. So look here students, H, how to represent HCH3 on this carbon. On this carbon HCH3. So hydrogens on the same side, methyl groups on the same side. Hence it is called as cis-2-butane. Coming to the trans isomer, C double bond C. Okay. CH3 is this side, hydrogen is this side, hydrogen is this side, CH3 is this side. So hydrogens on the opposite side, methyl groups on the opposite side. Then such isomer we call it as trans isomer. As it is 2-butane, we call it as trans 2-butane. Clear? Next example, malic acid and fumaric acid. So what is this malic acid? Doubly bonded carbon atoms. On this carbon there is H, COOH. On this carbon it has H and COH. So the carboxylic groups on the same side, hydrogen atoms on the same side. Hence it is cis isomer. We call it as malic acid. It is a dicarboxylic acid, students. Next, opposite one is fumaric acid. C double bond C. Carboxylic groups on the opposite side, hydrogens on the opposite side. So such isomer, such geometrical isomer, we call it as trans isomer, and it is fumaric acid. Okay. So you can quote these examples when you are asked geometrical isomerism in your exam, students. Okay. So writing the introduction, first what geometrical isomerism is, and next what stereoisomerism is, what geometrical isomers are, what cis isomer is, what trans isomer is, and hence it is called as cis trans isomer. Show the representations and give 2 examples, students. Okay. So this is all for today's class, students, and those who are watching for the first time, please subscribe the channel, and also those who have already subscribed, please like the video and share it with your friends, students. So please be updated for the next video. Kindly turn on the notifications. If you subscribe the channel, you will be getting all the notifications, students. Please kindly subscribe, like and share. So thank you all, students. Take care. Bye-bye.